Today I'm going to show you on an example of a line and a plane vector type of question. You can see that this question, we are given a line PQ. It's passing through the point P and Q, and the coordinate of P and Q are given. We are also given the plane, the equation of the plane. So the first part of the question is asking us to find the acute angle between the line PQ and the plane. Okay, so to do that, the first thing is that we are given the equation of the plane. So we have the normal vector for the plane. So the normal for the plane will be, so I'm going to write it down. The normal for the plane will be 1, 1, 1, ijk. And the next thing to do is to find the directional vector for PQ, the line PQ. So I have my direction vector. To find that, we have to use OQ minus OP. So we're gonna put the coordinate down, and if we're gonna solve this, you'll get 2, 1 minus 2. Since the coordinate of OQ is given and OP is given as well, so we can just do the math. You get 2, 1, negative 2. That's for the directional vector for PQ. So we'll be using the formula for this. It will be sine theta, and I have my direction vector for PQ, normal vector for the plane. So I will have something like this. So this is the formula. So we're gonna put the values in. So we're gonna put the values inside. So I have 2, 1, negative 2 for this, and I have my, I'm gonna scalar product with this, my normal vector for the plane 1, 1, 1, and I'm gonna square root this. So if I'm gonna square root this, I'm gonna get, okay, so I'm just gonna write down so this will be 1 square plus 1 square plus 1 square. So when you solve this, you're going to sine inverse whatever on the right hand side. That will get you your acute angle to be 11.1 degree. So we have found the acute angle between the line PQ and the plane. The next thing that they are asking for is the point of intersection between the line PQ and the plane. As you can see here that the line PQ is intersecting the plane at point A. I have labeled it as point A. So the first thing to do is to find the equation of the line PQ. So I'm going to write it down for you to see that the line PQ have the equation of, so I'm going to just put one of the point, I'm either P or Q. So I'm going to put it 3, 0, 1. I'm going to choose Q, and I have my direction vector found previously to be 2, 1 minus 2. So I have my equation of the line PQ. So I'm going to write my line PQ. So this line is going to intersect the plane, and I have my equation of the plane there. So I'm going to substitute the R into the R of the plane. So, but before that, I'm going to combine it together, and this will get you 3. Okay, I'm going to solve this. You're just going to combine it together. You're going to get this, and I'm going to substitute it into the equation of the plane. So we have something like this. Okay, and it's going to be 1, 1, 1. That's the normal for the plane, and if you're going to solve this, you're going to get this unknown. Okay, so what you're going to do, that this means that the line is intersecting with the plane, and you're going to substitute this into the line. So if you're going to substitute this unknown into the line, so you're going to get something like this. So we're going to put it into the line, Alright, so once you solve this, you're going to combine it together and you'll get the coordinate to be 5, 1, minus 1. So you're just going to solve, and if you have an unknown, you just substitute back into the equation of the line, and that will get you the point of intersection, the coordinate for the point of intersection, and that will be your A. So for the next question, we are asked to find the foot of the perpendicular from Q to the plane. So I'm going to let that be my N. I'm going to add an N here. So I'm going to add an N here. So this will be my N, and it's lying on the plane. So you can see that QN is a straight line making a perpendicular to the plane. So we're going to find the coordinate of N, or ON. So to do that, we need to have the equation of the line QN. So the equation of the line QN is going to be my R. Okay, I'm not going to write this like equal, so if not it's going to be confusing for you. So we have this equation. To find the equation of the line QN, I'm going to use the coordinate of Q. Okay, so Q is 3, 0, 1, and I have my direction vector. So what's my direction vector for this? So since the normal vector for the plane is 1, 1, 1, so for the line QN, since it's along the normal vector for the line, for the equation of the plane, so the direction vector for QN will be my 1, 1, 1 in this case. Okay, so we're going to combine it together. So this will get you, okay. Alright, so once you have this, we're going to substitute this into the equation of the plane, because this line QN is intersecting the plane at N. So I'm going to substitute this into the equation of the plane, and this is going to get me something like this. Okay, so once we get this, all we need to do is to solve for it. So we're going to get an unknown. So we're going to get an unknown. This means that the line is intersecting the plane. And to find the coordinate of N, we just have to substitute this 1 over 3 into the equation of the line QN, and there you go, you get the coordinate of N. Okay, so you get my ON there. So we have my ON to be 3, 0, 1. Okay, so once you solve this, you're gonna get this 10 over 3, 1 over 3, and 4 over 3. Okay, so you can see here that this is the coordinate of ON, X, Y, and Z. So to write it in a coordinate form, we will have 10 over 3, 1 over 3, and 4 over 3. So that is how you find the coordinate of N from the line QN intersecting with a plane. This is the foot of the perpendicular QN to the plane. For the next question, they want us to find the position vector of Q prime, which is the reflection of Q in the plane. So we're going to find OQ prime. And you can see here I have labeled it there for you to see. And since it's a reflection, the line QN to and the line NQ prime, they must be equal, right? Because it's a reflection, just like how you look in the mirror. The distance from you to the mirror and the image from the mirror to the image is the same. Okay, and once we get that, all we need to do is to write it down. How do you solve this? You can see that since Qn and NQ are equal, this means that my ON, okay, my ON is actually OQ plus OQ prime over 2. So we're going to, since ON is in the middle of Q and Q prime, we can just take OQ plus OQ prime, add them together, divide by 2, and there you go, you got your ON. So all you need to do now is to find my OQ prime. So we're going to move this around. You get OQ prime 2ON minus OQ. Okay, so since we have found our coordinate for ON, we just have to substitute inside here, and I have my coordinate of OQ is given to me in the question, and you can just put it down inside. So you have something like this: 10 over 3, 1 over 3, and 4 over 3 minus my OQ. You're going to solve this and you get your OQ. So the answer will be 1 over 3, 2 over 3, and 5 over 3. Now we're going to find the equation of the line P prime Q prime, which is the reflection of PQ. And that is in the plane. So how do we do that? So you can see that I have my Q prime there, and my P prime will be somewhere here. So it will be the reflection, so it will be somewhere here as well. So as you can see, we have my PQ and PQ prime, that's a reflection. And if you realize this, that AQ is actually the same as AQ prime. Not exactly the same, but it's just a reflection. So instead of using my P prime, since I have my Q prime, I can find my line PQ, my line P prime PQ, by using A and Q prime. So I'm going to do this. So we're not using P prime, since A to Q prime is enough to find the equation of the line P prime Q prime. So to do that, the first thing we have to do is to find the direction vector of P prime Q prime. And since P prime is along the line A and Q prime, we can just use the coordinate of A. So it will look something like this. So looks something like this: OQ prime minus my OA. And this will get me the direction vector of P prime Q prime. So you're going to just put it inside. You will have something like this: minus 4 over 3 minus 1 over 3 and minus 8. No, it's 8 over 3. Okay, so it's minus 4 over 3, minus 1 over 3, and 8 over 3. So I'm going to take out my 1 over 3. I'm going to simplify this. So I have minus 4, minus 1, and 8. So this is my direction vector of P prime Q prime. So we're going to put it down into the equation for the line P prime Q prime. So it's going to look something like this. So I'm going to use my coordinate of A. I can use any one of them. I can use Q prime or my A. So I'm going to use my coordinate of A. I'm going to add it inside here. Okay, later on I'm going to show you how to do that. So this will be my direction vector of PQ, P prime Q prime. Okay, so we're going to put it inside, and my OA will be 5, 1 minus 1 from the previous question that we found. And this is what we have found: minus 4, minus 1, and 8. And once you're done with that, you actually found the equation of the line P prime Q prime. They want us to find the shortest distance from Q to the plane. And you can see from here that our shortest distance is making a right angle to the plane, which is my QN. So all we need to do is to find the vector for QN, and that will be my ON minus OQ. So we're going to put the values in. We have my ON found from the previous question. OQ is given. So if you're going to solve this, you get 1 over 3, 1 over 3, and 1 over 3. So what you're going to do here right now is just to find the magnitude of QN. So it's going to be square root my 1 over 3 square plus my 1 over 3 square plus my 1 over 3 square. And once you press this inside the calculator, you're gonna get something like this: square root 3 over 3, and if you rationalize it, you get 1 over square root 3. For this question, we want to find the length of the projection of PQ onto the plane. So I've drawn this out for you to see. Okay, it's a 2D image. So to find the length of the projection of PQ onto the plane, we're going to use this. So I have, okay, so we're going to have my PQ cross product, vector product with n hat, and this will get me something like this. So we're going to put my PQ inside, but to do that we have to find PQ first. We have not found PQ, so PQ is going to be my OQ minus OP. So it's going to be my OQ minus OP. So we're going to put the coordinates inside, and you get 2, 1 minus 2. So we're going to put it inside here, 2, 1 minus 2. We're going to cross product with this. So this n is my normal vector of the plane, so I have 1, 1, 1, and you're gonna get square root 3. So if you're gonna solve this, you're gonna get 1 over square root 3, 3 minus 4 and 1. So when you do this, you take out you factorize out the 1 over square root 3 first, then you're going to cross product with the things that are inside, and you get this. And to find the distance, all we need to do is to square root 3 square plus -4 bracket square plus 1 square. And you're going to press this in your calculator, okay, and you get the answer for the shortest distance. So at the end of the day, you're gonna get something like square root 78 over 3 units. Okay, so that's how you find the shortest distance, sorry, not the shortest distance, the length of projection of PQ onto the plane. Okay, so we're gonna go on with the last question to find the length of the projection of PQ onto the normal of the plane. Now to find the length of projection of PQ onto a normal of the plane. So the normal, we have known that the normal of the plane is actually my QN. So this is my normal, right? My QN is my normal. So we want to find the length of projection, not the shortest distance, but the length of projection of PQ onto the normal. So this is the distance that I want to find. This is the distance. Okay, so we want to find the length. To do that, we're going to use scalar product instead. So we're going to use PQ from the previous question that we found, and we're going to scalar product with my normal vector of the plane. Okay, so it will be the n hat, same thing, and if you're going to solve this, you'll get your answer to be square root 3 over 3 units.